An overheating main breaker is a serious electrical problem that needs immediate attention. Let's consider several potential causes and troubleshooting steps beyond just a theory of overall load on the bus system. Firstly, overloaded circuits are a key area to investigate. Even though no individual circuits are tripping, the cumulative effect of all running appliances and devices might be exceeding the 100 amp capacity of the main breaker. To determine if this is the case, use a clamp meter to measure the actual current draw on the main feeder conductors. Compare this measured value to the breaker's 100 amp rating. Remember to conduct this measurement under typical load conditions when all major appliances are operating, such as the spa, oven, air conditioner if it is on, and the evaporative coolers. If the measured current approaches or exceeds 80 amps, which is 80% of the breaker's rating, this suggests an overloaded circuit. This overload situation is further exacerbated by the fact that breakers are rated to operate at 80% of their face value for continuous loads. Secondly, loose connections are a frequent cause of overheating in electrical systems. Carefully inspect all connections associated with the main breaker, including the points where it clips onto the bus bars, the terminals where the feeder wires connect to the breaker, and all connections of the individual breakers within the panel. Loose connections create electrical resistance. This resistance generates heat, which can damage the breaker and surrounding components. Be sure to tighten any loose screws or terminals to the manufacturer's specified torque. If you find any signs of corrosion or damage to the connections, the components will need replacement by a qualified electrician. Thirdly, faulty wiring is a cause. Carefully examine the wiring that runs from the electrical meter to the panel and from the panel to the various appliances. Look for signs of damage, such as frayed insulation, kinks, or improper installation. Overheating of the main breaker can sometimes be an indicator of loose connections or faulty wiring within the system. If you discover any issues, make sure the wiring is replaced or repaired by a qualified electrician, always following the applicable electrical codes. Fourthly, the breaker itself might be faulty, but this is statistically unlikely if two different breakers have failed in a similar manner. However, it is still possible that the replacement breaker could have a defect. It is wise to contact the breaker manufacturer to report the issue and request a replacement if the problem persists after other potential causes are ruled out. Provide the manufacturer with the breaker's model number, date code, and a detailed description of the failure. Fifthly, other factors such as high ambient temperatures or poor ventilation can also contribute to overheating. Check the location of the electrical panel. If it is in a hot attic or another area with limited airflow, the elevated temperatures can exacerbate any existing electrical issues. Consider installing a fan to improve ventilation around the panel. Ensure that there is sufficient clearance around the panel to allow for proper airflow. Avoid storing items in front of the panel that could obstruct ventilation. Also, high ambient temperatures can contribute to the problem, especially if the panel is located in direct sunlight or near other heat sources. Remember to consider that the ambient temperature inside the electrical panel affects the breaker's ability to dissipate heat. Consider these other factors as well. The age of the electrical panel and its components can also be a contributing factor. Over time, the insulation on wires can deteriorate, connections can corrode, and breakers can become less reliable. If the panel is very old, upgrading to a newer model might be a prudent decision, especially if other problems are present. The type of loads connected to the electrical panel can also affect its performance. Continuous loads, such as electric heaters, water heaters, and air conditioners, draw current for extended periods. This can put a strain on the electrical system and increase the risk of overheating. Try to balance the loads across different circuits to minimize the stress on the main breaker. Moreover, it's crucial to verify that the main breaker is properly sized for the service entrance conductors. The breaker should protect the conductors from overcurrent. If the breaker is undersized, it will trip frequently. If it is oversized, it will not provide adequate protection and the conductors could overheat. Refer to the National Electrical Code, NEC Table 310.15b16 to determine the appropriate conductor size for the service entrance based on the ampacity rating. Also, A whole house surge protector installed at the main electrical panel can help protect against voltage spikes and surges that can damage electrical components. Surges can weaken the insulation on wires and contribute to overheating. A surge protector diverts excess voltage away from sensitive equipment. Always remember, safety is paramount when working with electricity. If you are not comfortable performing these troubleshooting steps yourself, it's best to consult with a qualified electrician. They have the expertise and equipment to diagnose and resolve electrical problems safely. Upgrading to a 200 amp service is a reasonable solution if the total load exceeds the capacity of the existing 100 amp system. However, a thorough troubleshooting process is essential to identify and resolve any underlying issues before undertaking such a major upgrade. Ignoring the underlying problems can lead to continued issues even after the upgrade is completed. Start by measuring the total load on the existing system to determine if an upgrade is truly necessary. Calculate the demand load according to NEC Article 220. This calculation takes into account the diversity of the loads, recognizing that not all appliances will operate at their maximum rating simultaneously. If the calculated demand load exceeds 80% of the 100 amp service capacity, upgrading to a 200 amp service might be a good idea. When upgrading the service, make sure that the service entrance conductors and the meter are also upgraded to match the new 200 amp capacity. The existing meter might not be rated for 200 amps, and the service entrance conductors might be too small to handle the increased current. Also, upgrading the service often requires coordination with the local utility company. They will need to upgrade their equipment to provide the increased power capacity to the home. Obtain all necessary permits and inspections for the upgrade to ensure that the work is done safely and in accordance with the electrical codes. Remember, working with electricity can be dangerous. If you are not comfortable performing the upgrade yourself, it's best to hire a licensed electrician to do the work.